we are going to discuss about unit 4, in which we are going to, the unit 4 is condensed matter physics. This has 3 parts. One is band theory of solids, semiconductors, and superconductivity. So let's take the first one, that is band theory of solids in this unit. In the band theory of solids, the first thing we are going to deal with is formation of energy bands in case of solids. For this, we'll start with our basic knowledge. We know about the atom, as atom has the nucleus and different orbits around it, and the electrons will be revolving around the nucleus in different orbits. The energy of electrons in different orbits is different. The energy of the electron in the innermost orbit is less compared to that of the higher energy orbit and the higher energy orbit. So the energy of these electrons can be depicted in the form of energy levels. For example, this electron has the lowest energy. We can show a energy level corresponding to this energy of the electron, and we call this as the even or the ground state energy level. The energy of the next electron is little higher. We can show quantum mechanically the energy of the next electron in the next energy level as E2, and the energy of the next electron in the next orbit can be shown in the next higher level, and it is E3. In this way, as many number of electrons we have in an atom, we can show the number of energy levels. This is the basic knowledge we all have about it. Okay, let's see if we bring two atoms closer to each other, an atom and another atom. Let's take, for example, the hydrogen atom, because it's the simplest one. As we all know, the hydrogen atom contains one electron in its orbit. Let's take one hydrogen atom here. This is the electron, and this is the central one is the nucleus, and this is the orbit. This is one more orbit. This is the one more orbit. As we know, it has only one electron, and let's draw one more hydrogen atom here. These are the different allowed energy orbits for the hydrogen atom. Let us consider one more electron in the lowest orbit. So this is the one hydrogen atom, and this is another hydrogen atom. If I draw the energy level for this electron, single electron, the electron is corresponding to the lowest possible energy. We can show it in the ground state as even. This also corresponds to the energy level even. If you give energy to this hydrogen atom, then this electron will absorb that much of energy. It may go to the next higher orbit, and so on. What if these hydrogen atoms are brought closer to each other? Thus, bringing them to close to each other leads to the formation of bands. Let's take these two hydrogen atoms brought very close to each other like this. The hydrogen atoms are brought closer. There is no much distance between them. Now when these are brought closer and closer, initially if there is an electron in the outermost orbit of both the atoms, they will interact first. If we have the electron here, if the distance is lesser, these are going to interact. If still we reduce the distance, these are going to interact. For example, let us consider this electron in the innermost orbit is only going to interact with each other. The interaction is such that one of the electron reduces its energy and the other electron increases this energy. So how we can show this is the energy of the first electron, it is reduced, it was even, let's take this as even dash. Now this is again, it was even, now its energy is slightly increased, we can show that it is even double dash. So when these are brought close to each other and form as the single system, so the single energy level are going to split into two energy levels. Now think of bringing three hydrogen atoms close to each other. We are bringing three hydrogen atoms close to each other such that they interact with each other. So this energy and this energy leads to the splitting up of three energy levels, that is 1, 2 and 3. If we bring n number of atoms close to each other, then what is going to happen? The energies of all these atoms, which are n in number, are going to split into n number of levels. So this is 1 E1, let's take E2, and this is E3, E4 and so on. So we can have as many number of energy levels as the number of atoms are interacting. If there are n number of atoms, then the energy levels will be split into n in number. So this n number of energy levels correspond to the energy of the innermost electron of all the hydrogen atom which are closely interacting with each other. Now this, when we look to these energy levels, they are no more looking like separate energy levels. The difference between the each energy level is very less. They are very closely spaced. Hence, instead of looking them as an individual energy level, we can feel this as if a band. So if I take now generally a solid. Solid is a material which has the number of atoms arranged very closely to each other. The atoms are packed very close to each other in case of solids. So every electron of one atom can interact with the other electron. In this way, all the electrons will be interacting with the neighboring atoms or the atoms in the solids, which leads to the formation of the bands. Here we understand about the formation of energy bands in case of solids. Now these energy bands can be classified into two groups. One is valence band and another one is conduction band, which will tell us how these solids are classified into three main types. One is the conductor, insulator and the semiconductor. So let's take the bands now. So if the atoms in case of solid has the atoms something like this, and the electrons are the electrons in the orbits, which are the outermost orbits, and these orbits are known as valence orbits, and the energy corresponding to valence orbits is the valence electron. If all the valence electron energy level is drawn, the energy level looks something like this. The energy of these electrons is very close to each other of how many number of atoms we have, and this we call it as the valence band. Now if there are electrons in the solid which are not bound to any of the atoms, which have excess amount of energy, and those electrons we call them as the conduction electrons. So if there are electrons in your solid which are the conduction electron and which have the more number of energy, we call them as the energy level corresponding to these conduction electrons is nothing but the conduction band. So depending on the spacing between the valence band and the conduction band, the the materials can be classified into three groups. That is, solids can be classified into three main groups. One is conductors, and second one is semiconductors, and the third one is insulators. So how do we differentiate between these three now? All of you know about this. Conductor, this gap, what we say, this gap is usually known as forbidden gap. If there is no forbidden gap, if the conduction band overlaps to the valence band, then we call the material to be a conductor. If this gap is very small, maximum of the order of 3 electron volt, we call this as the insulator. If this gap is 3 electron volt maximum, then we call this as the semiconductor. If this gap is more than 3 electron volt, then we call the material to be insulator. So we understand from this part of topic how the materials are classified into three main groups: conductors, semiconductors and insulators, depending on the bands, and how the bands are formed in case of solids. Thank you.